So my name is Naylor, and this is my materials recommendation presentation for Hanger Incorporated. So our client's needs are, we need to make two bone and teeth implants that have to fit bones and teeth respectively, so they have to act and feel like bones, they have to look like bones. They have to be easy to produce, so the materials that are used to make the bones and teeth have to be easily accessible, so we can't go very far and can't be very expensive to get them. And that also goes with affordable, so the materials that we use have to be inexpensive, so that translates into a lower price for the consumer. So our constraints are that we have to have two different models for both bones and teeth. So we need to have a base model that's less expensive, more expensive, and then we need a cheaper model for people without insurance. So that will translate back to the materials and the types of materials. And then the bones and teeth implants have to act and feel like bones, so that they have to fit bones and teeth respectively. They have to act and feel like something that would already be in the body, and the body cannot reject what's being put in it. So the three properties we looked at in order to meet these needs and our constraints were toxicity, solubility, and hardness. So the material has to be non-toxic because it's going into the body, and we don't want anything in our bodies that would harm us. It has to be soluble or non-soluble, so it can't dissolve in water, it can't dissolve in any kind of fluid, because there's lots of fluids in the body, and if it dissolves in the body, then you won't have an implant in it anymore. And it has to be hard, so it has to be able to withstand what humans go through every day. So it has to go through running, jumping, hiking, anything that a human does, it has to be able to withstand, like a normal bone would. So we looked at 4 different categories of materials in order to pick a material for you. So the first category was a metal. So steel and platinum are examples of metals. Polymers, so examples would be acrylic resin, polyphenylene, and polyurethane. And then wooden fibers, so white pine, birch are 2 different kinds of wood. And then ceramics, so alumina, tungsten alloy, and silicon carbide are some examples. So for each of these categories, we looked at the properties of toxicity, solubility, and hardness for each. So the only 2 categories that we had to get rid of immediately were polymers and wooden fibers, because polymers are not hard at all, and that basically just takes them out of the picture, and wood fibers are not hard at all, or they're not hard at all either. So that's the biggest property that we were looking for, and because those 2 categories don't have them at all, we got rid of them. So we narrowed it down to 2 categories. So we narrowed it down to a metal. So because they have a large range of hardness, they can be toxic and they can be soluble. So you can find a metal that meets your need of being non-toxic and non-soluble and very hard. And then ceramics are very hard, non-soluble, and non-toxic. So we looked at them, and we've decided that both of these categories would be good to use in a bone and teeth implants. So we decided on titanium, which is a hard, non-toxic, and non-soluble metal, and it's easy to maintain. And then the ceramic that we chose was hydroxyapatite, and it's a well-known bioceramic, so it acts and feels like something that's already in the body and actually looks like bone when it's created into a bone form. So this is the model of our of a bone implant. The inside, the inner circles, would be the titanium core of the implant. The implant, say you had a femur, the inside of the femur would be a titanium core, and the outside would be the hydroxyapatite. And The intermolecular forces between the hydroxyapatite and the titanium allow them to stick together. They're both dipoles, and they can their molecules align so that they are attracted to each other. And this was the same thing would go for a tooth. You would have the titanium base, and then the hydroxyapatite would coat the bottom of the tooth so that it looked like a tooth. And these are just some sources on where we've learned about hydroxyapatite and its bioceramic qualities.